Hi there guys. Now what we're going to do in this video is take the general equation for a quadratic and complete the square on it, and you'll see hopefully where the quadratic formula came from. So we can prove the quadratic formula by completing the square on this. So it's a bit harder without the numbers, but let's just imagine these are numbers for the minute, and what we do is remove the constant term. So we would have a x squared plus bx, and that's equal to a negative c. So we're going to complete the square on here. Now when there is a coefficient, it's easier to just divide by this like we did in the previous video. So it'd be x squared plus b divided by a x equals minus c over a. Now we're ready to complete the square once we've removed the coefficient. So let's half the b over a. So please remember, b over a divided by 2 is the same as this. We change this, we flip this, it'd be the same as b over a times a half. So we end up with b over 2a, close the bracket, squared. Now we'd have to subtract this squared because that's what we'd get when we complete the square. So it'd be minus b squared, b times b is b squared, and 2a times 2a is 4a squared, equals minus c over a. So if you have an example that you've done with numbers alongside it, it will help you understand this one. Now what you'd normally do here is remove this term so we could begin to solve this easier. So we're going to add this whole term. And because when we add it becomes positive, I'm going to write that one first. So b squared over 4a squared minus c over a. So you should be able to see it is starting to look like the quadratic formula. Alright, here we go. So we can't leave it in this form because we've got two fractions being subtracted and the denominator is different, so we need to make them the same. So this denominator you can see is a factor of this one, so we can just multiply the one on the right by 4a. So that would be b squared over 4a squared. If we multiply this one by 4a, we'd have 4ac. Oops, let's get rid of that. Hurry up, computer. There we go. So 4ac over 4a squared. Now, again, it's getting really close to the formula. Now when we've got the denominators the same, we can combine these. So that's the same as this. Okay, and let's just bring this bit down. Okay, so normally we'd get rid of the squared now, so let's do that. So I need to square everything on this right hand side. So it's going to be, I'm going to do it like this. So it'd be the square root of this numerator. And the reason I'm not doing it over all of it is because I can actually square root this quite easily, because the square root of 4 is 2, and the square root of a squared, well, that's a times a, so the square root must be a. And we'd have this. Now to get x on its own, we're going to get rid of this term. Let me just check something, because I'm expecting it to be negative b when I move it over. Oh, I can't believe I've done this. So where this was a plus, I do apologise, that should be a plus, therefore that should be a plus. Just accidentally missed the plus off. So to get rid of this term, we'd subtract it, and then we would end up with our minus b over 2a. Remember, this is always going to give us a plus and a minus, so plus and a minus, b squared minus 4ac all over 2a. And you can see that we finished, but it doesn't quite look like the quadratic formula. But we have here, again, two fractions with the same denominator, so we can combine them, giving us negative b plus or minus the square root of b squared minus 4ac all over 2a. And there you have it. Oops, can't leave it like that. So with completing the square, you can go from the general equation of a quadratic all the way down to the quadratic formula. And that is how basically it was discovered.